In this example, we want to write the equation for the tangent line to the curve x squared plus 4xy plus y squared is equal to 13 at the point 2, 1. So remember, anytime that you want to write an equation for any sort of a line, we need to know the slope and we need to know a point. And we already have a point. We know the point on the curve is 2, 1. So basically we need to find the slope. So remember that the slope of a tangent line in calculus is the derivative. So we could write that as y prime. We could also write that as dy dx. So we need to compute the derivative of the curve we have here with respect to x, so dy dx. And since this is an implicit equation, and remember, it's implicit because we have not solved explicitly for one of the variables. We have this kind of mixture of variables together in the equation. We're going to use implicit differentiation here. So we're going to start by taking the derivative of each term, essentially. So the derivative with respect to x of the first term, which is x squared, plus the derivative with respect to x of the second term, 4xy. And I can take the derivative of all three of these terms individually, remember, because they're being added to one another. And then what I do to the left side, I must also do to the right. So I'm taking the derivative basically of both sides. Now I'm being really careful with my variables. This term contains an x, and we're taking the derivative with respect to x. So we'll just use our power rule there. The derivative of x squared is 2x. However, our next term, you'll notice, it contains a y, and we're taking a derivative with respect to x. So we are going to have to use the chain rule here. In addition, we have to recognize that this is a product, that we have multiplication here, 4x times y, and I like to go ahead and keep the 4 with the x and treat it like that, 4x times y. So this is a product, and we're going to have to use the product rule. So we're adding on, I'm going to do in red, the product rule. So product rule says we're going to take the first function that we're multiplying, which is the 4x, and then we'll multiply that by the derivative of y, but the derivative of y with respect to x is dy dx, plus the second function, which is a y, times the derivative of 4x, which will just be 4. So that is my product rule. And then moving on, we have plus the derivative of y squared. So that, again, I have to treat this like it's a composite function. So one way to think of it is like my outer function is something squared, and my inner function is the function y. Now remember, y isn't this unknown. It's an unknown equation, if you will, but it would be in terms of x. So the derivative of something squared will be 2 times something, and then the derivative of y, since we're taking the derivative with respect to x, that would be dy dx. So the derivative of y squared will be 2y times dy dx. And then on the other side, the derivative of 13 will just be 0. So looking on the left side, we want to basically take account of all of my dy dx's, since this is what I'm trying to solve for. So I'm going to go ahead and leave these two terms on the left-hand side of my equation and move my other terms to the other side. So 4x dy dx plus 2y dy dx is equal to negative 2x minus 4y. I went ahead and reordered this y times 4 to be 4y, and then I'll factor. Factoring out a dy dx, so dy dx times 4x plus 2y is equal to negative 2x minus 4y, which then allows me finally to divide. So now we have negative 2x minus 4y, all divided by 4x plus 2y. And it turns out every term is divisible by 2 here, so we could go ahead and divide everything by 2 and simplify a little bit further. Negative x minus 2y divided by 2x plus y is what I have right now for dy dx. Now remember, this represents the slope of the tangent line at any point on the curve, and we want the slope specifically at the point 2, 1. So one way to notate that is to draw a vertical line and put the coordinate down here, 2, 1. And that's just telling the reader that you're going to be substituting in 2 for x and 1 for y. So that would be negative 2 minus 2 times 1, all divided by 2 times 2 plus 1. So that looks like negative 4 divided by 5. And again, that's the slope of the tangent line specifically at the coordinate 2, 1. So then to finish this off, we want to actually write the equation for the line. And remember, we know the point on the line is the point 2, 1. And since that point is not the y-intercept, this is where I would go ahead and use point slope rather than slope-intercept form. So I would just go ahead and write this as y minus 1 equals negative 4/5 times x minus 2. And on a written exam, this would be an acceptable answer. This is the equation for the tangent line written in point slope form. But of course, if you wanted to go ahead and distribute this, you certainly could distribute and then write your final answer in slope intercept form. That would be perfectly fine as well.